Ladies and gentlemen, boys and girls, kids of all ages, it is my honor to introduce to you two extraordinary people, the administrator of NASA himself, Charlie Bolden, the head of the Jet Propulsion Lab, Charles Elachi. Gentlemen, come on up. So, do you each want to take a lectern? I would use the expression grab a lectern, but both microphones are hot.
Good.
Are these hot? No. I'll come over here.
We'll just work this. How's this? We'll just work
what
this.
You will do, you'll say a few inspiring words, and then you will acknowledge that what we're going to do tonight is quite risky. And then you guys will ask insightful, brilliant questions. So get right on that insightful, brilliant question asking.
That's right.
Dr.
Well, great.
Dr. Bolden,
come on up here, Dr. Elachi. This is Charles Elachi, and he's doing all the work. Charles runs for those of you who may not know, he runs the Jet Propulsion Labs for NASA, which is not very far from here. And I'm from Washington, so I came to help.
Yeah, great.
But we're really excited about tonight. We've had, it's actually been a great few weeks for all of us at NASA, but we're really, really, really excited about tonight. I think most of you, if not all of you, have probably seen the 7 minutes of terror, and I hope by now you understand why the engineers say that. If not, Charles will be able to answer the question for you. But I kind of put it in this perspective. Let me do it that way, since I'm a shuttle guy, all right? When shuttle comes back to Earth, because Earth's atmosphere is so thick, it's a half hour, kind of plummeting down through the atmosphere, getting red hot. You know, you're worried about everything, but the pilots have control if they need to. If we see something wrong, we can adjust. I mean, shuttle had a cross range of 1,000 miles, for example. With a robotic spacecraft, like, you know, the Mars Science Laboratory, and then the whole vehicle, the lander and everything that Curiosity is going to be in tonight, Charles's guys have been watching it for 8.5 months now, and it's on course, and they've sent their last command. And, you know, so now we're all along for the ride, and we're all getting butterflies. I can only speak for myself. We're getting butterflies. We're starting to sweat when it's not hot. And yes, ladies, I understand, okay, I do that too. But it's really an exciting time for all of us, because this particular mission is something that I think will just change the course of humanity's interaction with other planets. You know, when Curiosity lands on the surface of Mars tonight, brand new ball game. I mean, it is a huge rover. It's got 10 laboratories on it. It's just going to do incredible things. So let me let Charles say a couple of words, and then, if you all don't mind, we'll take maybe a handful of questions or something from you.
So I want to thank Charlie. Always when there is help from Washington, it's always welcome. Well, one thing I think which really describe what a great agency we have and what a great nation we have. Tonight at 9:15, I would suggest you go out and look towards the southwest, and you are going to see next to Saturn, there will be Mars, which is setting. And just stand for a second and think that we are landing a rover on that planet in an hour and a half after that. And then to make it a little bit more dramatic, if you wait a couple more minutes, then you see the space station coming up, rising very close to Mars. And by looking at that picture, that's what reflects what our country and what our agency is doing. We are doing what we do mighty things. I hope for the young people who are here, we leave you the legacy of then you carrying, you know, the flag and the torch to keep exploring and really take us beyond, both intellectually and one day physically, beyond our Earth's orbit. So it's great to have you all here. The spacecraft is doing very well. We canceled the correction maneuvers, which is scheduled for earlier today because it's dead on. I was giving in comparison the accuracy with which the accuracy with which we are approaching Mars. It's the same as if you launch a spacecraft from Cape Kennedy, send it toward the Rose Bowl, and we land on a specific seat in the Rose Bowl. That's how accurate, we are coming in. However, the challenge is still ahead of us. So those 7 minutes of terror, so we'll all be sitting watching what's going to happen. But I can tell you, no matter what happened, we already have accomplished a lot. The team has accomplished tremendous things. We have accomplished all the technology, the engineering, the development. Everything was done here in the United States. All that advances have happened here. And hopefully we'll be successful. But in this business of exploration, there is always the risk of things not going the right way. If that's what happened, we're going to learn from it, we'll stand up, and we'll go back to Mars again. Thank you very much.
Right. So you're going to drop a car from a rocket-powered crane. What could go wrong? No, this is great. Everybody, please, if you have questions, come up to the microphones. And I'll just tell you from experience, the most productive thing is if you have a question. So please, let's start over here.
Dr. Elachi, I am very impressed by your long career, and I am curious about not just the Mars expedition, but earlier expeditions of which there are now a great number. And if I understand correctly, the Deep Space Network has only so much ability to take care of data. How will resources in the Deep Space Network be allocated? And your pet project, which I believe is now leaving the solar system and which hasn't received nearly enough publicity by comparison with this Mars project. I'm hoping those signals are also being given their due attention. And my big question is, how are the signals different? What is the packaging? How are they being transmitted that's different between the missions that went out 30, 40 years ago and the ones that are being sent out today?
Okay, is that the difference, you said?
Yeah.
The difference between 4 years ago, you said?
No, the missions like Explorer and Mariner.
Oh, I see. Oh, I see, okay. Well, let me give you a feel about the Deep Space Network, because that's what you're referring to about the signal to it. 40 years ago, we would have been lucky that we just get something in Earth's orbit. Today, if you take when Voyager was at Uranus, the signal which was coming from it, which received by the DSN, you would have had to integrate it for 300 billion years. That's longer than the life of the universe, to have enough energy to turn on a flash bulb. And we still get those images that we get. So that shows the amazing technology that at NASA we have developed, for receiving those signals. And you all are benefiting from it, because when you pull that cell phone and you make a phone call, the code on it was developed by NASA to communicate with our spacecraft. So this is the benefit that they got from the space program. Now, let me add one additional anecdote or a story so you are interested in. As you know, we have Deep Space Network across the planet. We have a station in Madrid, a station in Canberra, and a station in California here. It just happened that when we are landing, Mars will be over Canberra. So the first signal will be coming at the DSN station in Australia, and I can tell you, the people down under are so excited about it. The American ambassador is going to be at the station, in Canberra, and then the data will come and get pipelined to JPL and pipelined to you in real time.
Can you talk about how the signals are different between 40 and 50 years ago and today?
The difference in the signal itself?
Yes. What qualitatively, and why can we get more information more quickly?
Well, it's advances in technology that we have done. The coding that you have on your signal, the sensitivity in the antennas that we have. During Explorer 1, the first mission that we launched, that was at the speed of how fast I type. That's how much data we get. And I can tell you, I type very slowly. I type with one finger. Now you are getting data streamlined in real time. So these are the advances which have happened in my lifetime. And just imagine what's going to happen in these young people's lifetime here. That will be an amazing amount of, but that's the technology advances that have been accomplished, not only by us, but by the whole industry in the space program.
And the signals that are coming back from the very edge of the solar system.
We're going to have to go to one more question over here, all right?
Yeah. Artemis.
I'll chat with you after.
Thank you. My organization has led the Get Curious campaign, and we don't want it to stop tonight. We want to stay curious. And so my question is for NASA as a whole, for Mr. Bolden, for Mr. Elachi, but for whole NASA. What can we, as an audience, as a people in the United States, do to make sure that big missions, great missions like MSL Curiosity can happen again and again? What do you need from us?
What you can do is relatively simple, and there is something happening in a few months called an election. Yeah. And you vote for people who promote exploration and people who believe in the things that you want to believe in. And I know I'm not being trite when I say that. You should communicate with your congressmen and senators and let them know that you believe in this. NASA enjoys, I will tell you, in spite of everything you hear or in spite of everything going on, NASA enjoys strong bipartisan support in the Congress. And we have support in the administration. What we have to do, though, is we need to have the public dialogue where you all can tell people where I work in Washington, D.C., that exploration is really important to you as a taxpayer and that you want some of your taxpayer dollars to go to it. Otherwise, if they don't hear, then they will assume it's not a big deal. And Bill can talk much more about this than I can. But that's the one thing you can do is speak with your voices and visit and say, look, we got to have this. And teach your kids why it's important. It's incredible to see the few down here on the front row. I'm not going to Mars, in all probability, and many of you in here are not going to Mars. What's your name? Kevin? Kevin may go to Mars. See, Kevin, and I have 3 granddaughters, 12, 9, and 6. And I want my 3 granddaughters at least to have the option of going to Mars should they decide they want to do that. And I have one of them who considers herself a rocket scientist already. So I think she wants to go, but that's your role. My role is to go in and fight for what you want once you tell us that's it, and to try to find an effective way to spend whatever of your taxpayer dollars we get, and that's our responsibility. And then, like I tell people, we've got to deliver. You know, we have to put plans together, which is what we're trying to do with the folk at JPL and our international partners. We're trying to put together a new plan for Mars exploration that enables us to do what President Obama has said he wants us to do, which is put humans on Mars in the 2030s, in that decade. We can do that, but we need to start now. Curiosity, if it lands successfully or when it lands successfully tonight, that is a huge step to being able to put this young man on the surface of Mars in the 2030s. So that's
okay, way ahead of you. On 12th of September, there's a congressional space blitz. Anyone who's in Washington or plans to be there, please get to exploremars.org or to the National Space Society. We will get to Congress, not just then, but especially then. And keep an eye on that date, 12th of September, because we of Explore Mars have something else on the books. Keep an eye out.
We will be watching. So how many people are Planetary Society members? Look at that, Charles. These are the people that we send emails to and paper letters to advocate for exploration. We're just trying to change the world here. Let's take another question over here.
Hi, thank you. On the heels of what was just being discussed, before I get to my question, I just wanted to add that part of what I'm so proud of about our government spending money and our human resources on these efforts, rather than the commercial sector, is that the information is available. It's free, and it's JPL, I know, does everything possible to make sure that it's available as immediately as possible as well. If it were totally in private hands, we don't know that that would be the case. And also, I love our regulatory bodies. I think that it's important to have safety as part of this whole effort, especially with pollution and other things that are obviously going to be a problem with commercial efforts. So in any case, and I'm very proud of our government. My question is, and I'm sorry I wasn't here when Rob Manning spoke, so I don't know if he covered this, but I know that the jetpack, when it gets released, is going to land somewhere away from the landing site, and that there was a debate as to whether the rover would eventually be sent over there because the engineers would like to see what happened to the jetpack, but the scientists are concerned about contamination, and I was wondering if that has been decided. It must have been decided at this point.
Okay, let me describe to you the logic we followed. we found an area which is very exciting after debate by the science community and so on, which is just at the slope of one of the mountains, which is called Mount Sharp. But we wanted to land in a safe place also to do that. So the plan now is to land in an ellipse which is a few kilometers in size, and then we will be driving up to the exciting areas, you know, that were the scientific interest. And that probably will take us a couple of months to do that. So one of the things we urge everybody is just to be patient a little bit. Once we land, we are going to go and take a good night's sleep, and then we are going to sit down and understand, you know, the state of the rover, learn how to drive it, and so on, and then we will start heading, you know, toward the exciting areas. And I'll assure you, we're going to have a new discovery every day. We're going to be surprised every day. So we're going to be learning every day we drive, you know, learning about something new and adapt, you know, to do that. So it's going to be a very exciting, you know, endeavor in the next
And
few
isn't
years.
there, Charles, isn't there a technical thing? You don't want to go too near the tanks, which still might have fuel in them, right?
Oh, 2 years for what?
You don't want to drive up to the tanks on the sky crane that still might have enough stuff in them to affect the instruments. Can we say affect on television? Yeah.
No, you know, the sky crane you are referring to, that's the one which we are going to separate from it. We are not going to drive toward it.
Yeah, right.
And the reason is because it has hydrazine.
Yeah, hydrazine. Yeah.
And we
That's
don't
the
want
word
to,
effect.
we don't want to pollute, not pollute, what to say, to keep the purity of the instrument, because we are looking for organic material.
Yes, I
so we'll
see.
be driving in a different,
And if you
know, in a
spray
different
ammonia over the place, you're not going to find.
Right.
Yeah.
Thank you so much.
Sure.
What do you recommend for high school students who want to get into the field,
Who want to take
like work at NASA?
Oh, I'll tell you, my recommendation to anybody who wants to do anything, whether it's NASA or otherwise, is really challenge yourself in the classroom. You've got to have math and science. Now, you don't have to major in it, but I'd say you need to take math and science. You also need to take the language arts. You need to be able to speak and write and express yourselves. As an American kid, you also need a little history, because there is a saying that, you know, if you don't know history, you're bound to repeat it. And there are a lot of mistakes that we've made in getting to where we are today in terms of exploration and the like, so you need to understand some of that. But we don't just need, NASA doesn't just need scientists and engineers. We have a critical need for them, but we need doctors, we need lawyers, we need accountants, you name it. Each NASA center is sort of like a little city. And that little city has a need for all kinds of things. So you can actually become involved in the space program even if you're not a scientist or an engineer. I need lots of scientists and engineers, though, so that's why I say I'd encourage you to, when you go to college, major in some technical area and then go for it. You know, just go online. Right now we have something that's on, I guess it's Fed Jobs or something like that, and NASA is listed in terms of what kind of openings there are, and then put an application in. Are you a high school student now or a college student?
I'll be a senior in high school.
Okay. Start looking, go online again to our website, to www.nasa.gov, and under the education drop-down, look for internships, because we have high school interns, we have college and university interns and co-ops. There are a number of programs that you can get involved in or you can apply for, and what that does is it allows you to see firsthand what we do. You may find that, I really don't want to do that. I want to go work for some other company, or I want to go work for something else. But it gives you an opportunity to see what life is like at a NASA center. If you've not been to JPL, I would say you ought to plan a trip there with your class or something else where they can show you what goes on day in and day out, and that'll help you to shape your thinking also about what you want to do next.
Thanks.
Let me add one thing, consider you probably are local from here. In the summer, we have 500 students who work at JPL, starting from the age of 16, so high school and above. So make sure you look into, I mean, it's too late for this summer, we're halfway through it. But for next year, in January or February, go on our website, and we bring students who come and work during the summer. That will give you a good feel about the excitement at working at NASA.
And it doesn't, I mean, you don't have to come to JPL. I tell Charles all the time, no, I'm just saying, my daughter, for example, I will give her, my daughter is now a plastic surgeon, but when she was your age, when she was a rising high school senior, she decided she wanted to go to someplace for the summer, and she found out that JPL had a summer program for high school. We thought it was for high school students. It was actually for rising college freshmen. She applied, was accepted, came out here and spent the summer at JPL, and actually was on a team that built the wheels for one of the earlier rovers on Mars. And so, I mean, that just completely cemented for her that whatever she was going to do was going to be in the field of science or engineering. And so she's a chemistry major. She's a, you know, she got a chemistry degree, a chemical engineering degree, and then decided to go to med school. So go figure.
Thanks.
So does she hustle academically? She just, no, geez. Chemical engineering and then med school, how relaxing. But it shows you what I like to call trickle-up economics. By investing in planetary science, JPL supports 500 students every summer. La Cañada High School is a better high school, the middle schools are better schools, the elementary schools are better schools. So everybody, when you get the chance, vote. Be sure to vote. If you're not going to vote, thank you. If you're not going to vote, would you please just shut up? Okay, just. So get out there, man. Next question. Oh, do you guys have to go? How are you doing?
I think we got a
Can we, a couple more minutes? Please.
Thank you, Sue, for your time today. With the legacy rovers that are down there now, they've greatly exceeded their lifespans, which is a good problem to have. If the same thing happens with Curiosity, do you see any issues with sustained funding over the long term for those programs?
Will the funding be sustained? Well, that is my job, if I may just say, as the head of the planetary site, to get you guys all motivated to write to Congress and the House of Representatives to sustain the funding.
I think the question was about the lifetime, you know,
Well,
how
if the
spiritual-
rover keeps roving, will the funding be around, Charlie?
Okay, let me let me tell you how we do things. We, on Curiosity, we committed for NASA that we will operate for 2 years, which means we test all the mechanisms on it for the equivalent of 6 years of operation. Okay, that's our process to guarantee the 2 years. Now, as you know, on Spirit and Opportunity, we guaranteed 90 days. We tested it for about 6 months, and that was 8 years ago. So what I'm challenging our team, I told them, when I'm retired and old, I want to see that rover at the top of that mountain, you know, 15 years from now, still working.
Right on. Two more questions. Here you go.
Very quickly, it's an honor to talk to both of you. My background, my father worked for NASA since 1957 as a PR officer, retired in '86 after the Challenger disaster. He worked at JPL. His name was KP Senstad. My sister, Beth Varish, is working the mission tonight. I'd like to see NASA, I've been to headquarters, I'd like to see NASA have more of a direction towards an unmanned space program. I really believe these children should go to Mars, but I think the path to that is through the unmanned program and using these vehicles that are being designed at JPL. I think over the next 30 years we can accomplish a lot more with a focus on unmanned programs than manned programs, and I just wonder how you feel about that.
Well, you know what I'm going to say because I'm a manned spaceflight guy, but I just...
He's a fighter pilot, people, and a shuttle pilot.
I will let Charles give you his opinion. I've asked before, you know, what if we had a human on Mars right now, what could we have discovered how long would it take a human to uncover many of the things that Opportunity has done in 8 years? And the answer to that is a minuscule amount of time. When you put a human, you can't send humans first, and that's why we do robotic precursors and everything. You can't responsibly do that. But when you combine humans and robots together, then the gain in knowledge, the gain in expertise is, I just don't think you can imagine what we can do. I don't disagree with you. We've got to fly more robotic missions if we're going to put humans on Mars in 2030. We need to have a soil sample. We're going to fly MAVEN next year that's going to give us information about Mars's upper atmosphere, but we've got to get a sample back here that we can put in a laboratory so that we know for sure what it's like there. I mean, Curiosity is going to equip the scientists at JPL and around the world to make great discoveries. Curiosity isn't going to discover anything. You need to remember that also. Curiosity is a robot. So it's your sister and it's other people at places like JPL and other places around the world that make the discoveries. The machines don't make the discoveries. The machines without people don't do anything. And I think when we, as we're trying to do now at NASA, we're trying more and more to synergize our science and our human exploration programs. The heavy lift launch vehicle that we're building now is not only to support humans to Mars and other places, but it's to make it possible for us to send planetary missions that we today can't afford to send. I mean, you know, it will cut down on the amount of time, it will increase the amount of payload we can send. So there are a lot of reasons that we're trying to tie these programs together. I know the lady made the comment about commercial. Commercial is important because it frees up NASA to be able to do the kinds of things that you all are talking about. NASA shouldn't be spending money on providing access to space, you know, on taking people back and forth to the International Space Station. That is never perfected, and it's never, I don't want to fool anybody. It's risky, it's dangerous, and it always will be. Going to space is dangerous stuff. That's why NASA does it, to be quite honest. We feel that it's our responsibility to take care of the dangerous stuff until we get it to a point where it's acceptable risk, an acceptable level of risk for private enterprise. We think we're there now on low Earth orbit access, and that's why we're handing off cargo carrying people within the next 3 years or so to the commercial entities, and they can do that very well. There's not enough money, if you want to get right down to the basics, not enough money for us to do access plus exploration. I'd much rather do what you said. I'd much rather do the exploration and then let private enterprise do the access, so hopefully. Okay.
Last question. Yeah. This is the last question. It's going to be a great one. You're ready. Here it goes.
So we've heard about 2 of the 3 of NASA's main objectives. What is aeronautics doing, particularly in hypersonics, in order to do another demonstrator? X-51 beat us on time. We haven't beat us on speed yet, and how are we going to use that to lower the cost of access to space and get better reusable boosters?
Thank you for the question. I mean, all the questions have been great. I'm a pilot, and I love talking about aeronautics, and it is the big A in NASA. You know, people need to remember that. We spend less money on aeronautics in NASA than we do on anything else. And yet, we enable the nation to accomplish our highest balance of trade is in aviation, is in production of airplanes and things that go through the air. Curiosity tonight, the 7 minutes of terror, that's hypersonic flight. So, you know, for people to say that we don't need to do basic research in aeronautics and we don't need to do basic research in things like hypersonics, that's just foolish. The reason that the 7 minutes tonight is going to be so horrifying for us is we don't fully understand the Martian atmosphere. We know a lot, but we don't have it down to a science like we do our own, and so Charles's guys have designed this entry trajectory based on what we think the Martian atmosphere is like, and we've been in wind tunnels and we've been other places, and we have some people who are expert in what we call entry, descent, and landing. I think you were talking about it earlier. That's hypersonic flight. You know, granted it's a thin atmosphere, but it's still an atmosphere, and it's no different, other than it's a thin atmosphere, it's no different than bringing a space shuttle back to Earth. You gotta fly through some fluid, and we're starting at incredible speeds, and like Charles will tell you, we got a doggone parachute that's gotta come out supersonically and stay together. I mean, that's the first thing. Both of us, we go, holy jeez. You know,
what could go wrong?
A supersonic parachute. This thing's gotta unfurl and just cause this thing to start slowing down enough so that we can fire the 8 jets to make this rocket hover over the surface of Mars. That's why it's scary, you know, because it has to turn into an airplane, a hypersonic airplane, in order for Curiosity to safely be put on the surface of Mars. So I'm with you. We need more aeronautics research.
So
Thanks for the question.
Let me close with one comment. Charlie kind of reminded me when talking about the speed with which we are coming. Just to give you some numbers, we're coming in at about 13,000 miles per hour. That means Charlie can go back to Washington in less than 10 minutes. That's how fast we're coming in. Now, many of you can sit down and calculate the energy. That's 1/2 mv squared. You know, some of the young people here know that. Now, that doesn't give you very much information. So let me tell you what that compared to. The energy when we hit the top of the atmosphere is the equivalent of 18,000 Indy 500 race cars. going at their highest speed. That's how much energy we are hitting that atmosphere. And within 7 minutes, we have to land at the same speed as somebody on a slow bike. So we're going from 18,000 race cars to on a slow bike just in those 7 minutes. And that's through heat shield, learning about the gliding through the atmosphere, parachute at supersonic speed, you know, retro rockets, and sky crane. Now you see why we are very nervous. Anyway, go Curiosity.
Thank you very much. To a safe journey and the joy of discovery, Charles Bolden and Charles Elachi.